Hey y'all, I want to go ahead and kind of experiment with you around this idea of for loops and just looping in general. So in this kind of play along lesson here, we're going to go ahead and we're going to experiment a little bit with looping and see what we can generate to see if we can create anything interesting. What we talked about this week was really this idea of loops, right? And being able to do the same thing over and over and over again. And what we're going to see here is we're going to see how we can use dynamic information using variables to kind of change how we draw stuff to the screen. So I'm here. I have a script here that is doing nothing, right? We just have a create canvas at 400, 400, and we have a background of 220. That's cool. The first thing I want to do here is I actually want to make the size of our canvas a variable. And we'll see why we want to do that a little bit later. So at the top here, I'm going to say var size, and we'll make this 400. And I'm going to now take these hard-coded 400s and put the size in there. That makes it so we can change the size of our canvas by simply changing this one variable, which is quite nice. Awesome. That's not really any loops, right? Now let's go ahead and I'm going to do this actually in the setup function because the setup function is only run once and we really only want to run this once. There's going to be no animation going on. So what I'm going to do is I'm actually going to take out this background call because the background call is going to paint the background over and over again. So if we drew anything up here, it would just get overwritten. So let's go ahead and let's draw something to the screen. So I'm going to draw, say, a rectangle, and we'll draw it at like 10, 10, and we'll make it a size of 10. Okay, awesome. We have this little tiny rectangle. Let's make it a little bit bigger. Oops, I'm sorry. Let's make it a little bit bigger. We'll make that bigger, and we could keep it at 10, 10. Okay, awesome. We know how to do this, right? We know how to draw basic shapes to the screen. But what if we wanted to, say, draw a bunch of rectangles to the screen? Something like this. Like if I wanted to draw a rectangle right next to this rectangle, I'd copy this line, take this. These first two parameters, as we know, are the x and y coordinates. So if we wanted to move this rectangle over to, say, here, right next to it, we would have to increment the x value, right? So this bad boy. So if we change this to 20, you can see we're moving over. So being that it's 100 pixels wide, we'd have to add 100 to this, right? Because we want to make it go all the way over. So if we go ahead and do that, we could just say 110. And now we have two rectangles butted up against each other. If we wanted to give it a little bit of padding, we could say maybe 115. Now we have a little bit of padding. If we wanted to add another one, that's really simple. All we have to do is copy and paste this line and then make this 215 or maybe a little bit more than that. So 220. Awesome. Okay. So that is now drawing another rectangle or square. Awesome. But now if we wanted to do this for everything on the screen or take up the entire screen with a grid of rectangles, that would be quite tedious. This is where loops come in. Loops will enable us to do a tiling of the screen with basically a single line within a loop. Now, the challenge here is that we need to now make these variables within it change dynamically based on where we're at in the loop, right? So let me go ahead and just write out a loop real quick. I'm going to go up here. I'm going to say for, and let's define a variable here. I'll call this variable I. We'll start it at 0. And I'm going to go ahead and keep looping while I is less than, say, 10. And then we'll go ahead and just increment I by 1. So this is the basic structure of a loop. We're able to just say, hey, we want to start at 0. We want to start the clock at 0. And we want to keep looping as long as I is less than 10. And we're going to go ahead and increment that I value, that variable, one time in every loop. So I'm going to take one of these rectangle function calls here, and I'm going to put it right in between these curly brackets, right? And we could take out these other bad boys right here. Now, we're back to only seeing one rectangle. Now, why do you think that is the case? Why do we only see one when we're looping essentially 10 times? Well, yeah, we have not changed these positions. So we're technically drawing 10 rectangles, but they're on top of each other. So in order for us to go ahead and tile this across the screen, or just across the x-axis, what we could do is we could increment the x-axis by some value. Now we could simply say plus I here, because inside of this loop, this I variable is actually incrementing. And you can see this, if I say plus I, you can see this very visually here, that there's this like black border now. That's cool, but it's not really what we're going for. We kind of want to tile across the screen. So what we could do is we could put parentheses here and say I, say times maybe 100. And now look at that. Now we see that they're tiling across the screen, because for every I, we're multiplying 100, which is going to increment that width by the width of the actual rectangle. So here, think about this at runtime. At the first loop, I is 0. So that means that it's going to resolve to this. Now 0 times 100 is 0. So the result is going to be 10, right? Now the second time we loop through, it's going to be 1. And now look what's happening to the rectangle. This is a very kind of visual explanation of what's happening here. You can see it moved over. If I say 2, it moved over again. If I say 3, it moved over again. Now what we're doing here is we're automating this 3 to automatically increment inside of this loop. So we don't have to do this manual step here. It's happening automatically because we have this loop in place. That makes sense. I know this is a little scary because we're just doing a little bit of math here. We're just saying, hey, we're adding this value to 10, and this value is changing depending on what value is in I. Now this is cool, but this really isn't all that interesting. What I'd like to do is I'd like to kind of build this out in a little bit more complex way. So I wanted to start this off, this assignment off with kind of a simple example showing you how we can use loops to kind of tile across the screen. But this is only going in one dimension, right? This is only going across the x-axis. And this may actually be a bit clearer if I said something like this. If I, instead of using I used x, which is essentially the same thing, but you can see that now we're really going across the x-axis. If we wanted to go across the y-axis, it gets a little bit more complicated. And I'm going to go into that in a minute, but I want to kind of frame a little bit of a journey here to get something visual on the screen. So there is this idea of generative art, right? And when I say generative art, I'm not talking about Gen AI. I'm talking about more writing code that generates interesting visuals, right? So we're going to step through this together and follow along with me. It's in a video format, so you can slow this down as much as you'd like. In some cases, I may move a little fast, but you can always back up a little bit. I'm going to try to kind of just throw together a little bit of a demonstration of an interesting kind of maze generator. We're going to generate some mazes on the screen. Now to do that, we need to be able to do one fundamental thing, and that's draw a line. We need to be able to draw a line, particularly draw a line on an angle. So if we know that, let's go ahead and write a function that can simply draw a line. So I'm going to go down to the end over here, and outside of any curly brackets, and I'm going to define a function called drawLine. Now we know that the P5.js framework already has a function for us to draw a line, but we need to put what we call a wrapper around that so that we can control the parameters to the line function a little bit more fine-tuned. So I'm going to pass in a couple of parameters to this, and it's going to look a lot like the line function. I'm going to pass in the x and y coordinate, and then we'll also pass in the width and the height. Okay, that's it. So now we have this little draw line function. We now need to actually draw the line. So I'm going to go ahead and we're going to say line. So we're going to use the internal P5.js function, and we're going to start at x and comma y, and then we're going to go to, let's say, x plus width, and then y plus width, y plus height, I'm sorry, y plus height. Okay, so now we have this function but it's not doing anything yet because we're not calling it. So I'm going to go ahead and take this loop out. We're going to take it out, and I'm just going to call the draw line here in the setup function. And I'm going to say draw a line from 0, 0, so the first point here in the upper left-hand corner, and we're going to go all the way down to the size of our canvas. So size, size. And you can see why we put this size inside of a variable now, because we're now using this size as our parameter to the width and the height of this draw line function. Now, cool, we just drew a line across the screen. I don't think any of us would classify this as any type of generative art, right? It's just a line. There's nothing really going on. We're not using any loops. It's just a line. Cool. Now, if I wanted to say, try to change how we draw this line, right? We can change these parameters. Maybe if I put 10, 10, you'll see this will move over a little bit, and it's really gonna give it a little more than that. You can see that it moves over a little bit. Cool, that's not really great. If we wanted to go ahead and say, flip the angle that this is drawing on, say for example, I'm gonna go ahead and comment this out, and I'll put another line call in here and say, let's go to X plus width. So we're gonna start the line on the far edge of the canvas, and then we're going to go to, let's say Y, and then X, and then Y plus height. So what this is going to essentially do is draw the line, but in the opposite way. So now we have the line going this way. So now we can draw a line going from this angle to this angle. Okay. We're kind of drawing, we're creating some kind of primitive structures here to create something a bit more interesting. And this is how this stuff kind of emerges, right? It starts with super, super basic geometry. There's nothing really that exciting about this. We're just drawing a line, and we're changing the parameters we're passing to it to be able to draw it on a different slope, right? Either ascending or descending, right? We're either going up the mountain or we're going down the mountain, right? So two different ways to draw the line. Now, what if we wanted to say, hey, let's add a little bit of randomness to this. Let's say we wanted to dynamically draw the line going down the mountain or up the mountain, depending on some random variable. So let's see what that does. And we're just experimenting here, right? So let's go ahead and say, I'm going to declare a variable, and let's call that variable left to right. And this is just going to be a random variable. I'm going to say, give me a random value between 0 and 1, which is actually the default for the random call. So you don't really need to put the 1 in there, but let's go ahead and do that just for being explicit. Awesome. Now we can actually make this a conditional statement by, with a little shorthand. So we can make this left to right 0 or 1 based on the value of this random. So say, for example, we wanted to say, hey, if left or right is greater than 0.5, right? So we could do something like this, greater than or equal to 0.5. Now, this left to right is going to be true or false, which is perfect for us because now we can use this in a conditional statement. So this little statement here is a little shorthand for making something what we call a Boolean value or a true or false value, which is great because now we can just simply write a conditional statement that is super simple. We don't have to do any real tests inside the conditional. So if we wanted to now draw a line either going on a slope or ascending, what we could do is we could say if left to right, we're going to go ahead and draw this line if it's left to right. So I'm going to put this inside of this. And then we're going to use an else statement. An else statement is basically a continuation of a conditional that says, hey, if this isn't true, then do this, right? So we'll go ahead and put this in here. Now, every time we draw this function, it's going to be random. Now, to illustrate this a little bit better, I'm going to go ahead and put this in the draw function because this draws a bunch of times. So we should see a cross now, right? We're going to see this like X on the screen because it's randomly drawing it, and In this case, it's going to just continuously draw on top of itself. So we can see that it's doing what we expect, right? And we can see that maybe a little bit better if I continuously run the program. See how it's drawing randomly either a slope that's left to right or a slope that's right to left. Okay, cool. But why are we doing this, right? What is the purpose of this? We're kind of just experimenting with this idea of randomizing how we draw a line. But what can we use this in? How can we make this a little bit more interesting? Well, let's combine this simple idea of drawing a random line up or down, which I think we would still agree that this really isn't anything artistic. This is just drawing a line, and we're experimenting with how we use conditional statements here and introduce this else statement to be able to conditionally do one thing or the other. But what if we combined what we did earlier with a loop? So let's try that. What if we put this inside of a loop and we did the same exact thing that we did with the rectangle at the beginning of this, but we did it with this new draw line wrapper function. Okay, so let's try to put this bad boy into a loop here. And now one thing you're going to want to do before we write this loop, because we are risking going into what we call an infinite loop, which will loop the program forever, is we want to turn off this auto refresh. So if you have this on, let's go ahead and turn that off. And now let's go ahead and write our loop. So the first loop we're going to do here is we're going to try to draw this line across the x-axis. So let's see what happens. If we say 4, and I'm going to say var x equals 0, we'll start at 0. And let's loop for as long as we are less than size. So I hope you see now we're using this size variable all over the place. And now we might need another variable here because we don't want to just do x plus plus. We might not want to step in the x plus plus direction because it's only going up by 1. But let's go ahead. I'm going to take this and put this in here. And I'm going to pass in now to the draw line. Instead of 0, 0, we're going to pass in the x parameter. And we don't want to go from size to size, right? We want to dynamically make this line a certain size, not the same size as the entire canvas, right? So I'm going to create another variable over here. I'm going to call it step. And let's make it to something, let's make it to like 20. And now, instead of using the size here, I'm going to use the step. All right, and now I'm going to hit play here. And let's see what happens here. Now we have all these different lines going across the screen. Interesting. They're all overlapping each other, it seems. It's kind of a mess there. What the heck is going on? Now, the problem here is that it doesn't really look interesting. I wouldn't say that's an interesting piece of artwork, but it is doing something. It is drawing across the entire screen on the x-axis, which is what we would expect. But it's going 1 pixel at a time across the entire screen. And our line is not 1 pixel in size. It's actually step in size, right? Or 20 in size. It's going by 20 pixels each time. So the length of the line is 20 pixels, but we're incrementing by 1 pixel. So what we can do is, instead of saying x plus plus, we could say x plus equals step. And now if we run this, now we can see our lines. Kind of interesting, a little bit more interesting than just drawing a basic line. We have this kind of lines just kind of growing across the screen, and they're changing the direction they're going in, which is creating this almost illusion of a continuous line in some cases and just kind of disparate lines in others, right? You see that, right? This one looks like an M. This one kind of looks like a slanted N, and this one kind of looks like just a zigzag, right? In reality, what we're doing in our program, though, is we're drawing just single lines, but because we have the randomizer in here, it's randomly going in either direction, either up the hill or down the hill. Okay, so that's cool. Not exactly art yet. Now here's where it gets interesting. Now, we can put loops inside of loops. Right? Like the movie Inception, right? We have dreams inside of dreams. So you could put loops inside of loops. And what that basically means is that for every outer loop, you're going to do all of the inner loops every time. So let me write this out and then I'll step through it a little bit. So inside of this for loop, I'm actually going to put another for loop. And instead of X, I'm going to use Y. And I'm going to say, let's loop as long as Y is less than size. And then we're going to increment Y by the same step. We're going to open our curlies, mindful of our curlies, and we want to take this draw line and we want to put it inside of this for loop. Now, this is a pretty advanced topic. Nested loops are something that we use in a bit more complex environments for specific reasons. For screens, it makes a lot of sense because what we're doing is we're basically segmenting the screen on the x-axis, and then for every x-axis, we're going down in the y direction. So you can think of this as a row and a column, and we're going across all the rows, and then for every row, we're going down all the way to the bottom in a column. Does that make sense? So we got kind of a row and a column thing. So that's one way to look at it. You can even call it row and column in the variable names if that makes it a little easier to visualize. But now, if we run this, let's see what happens. Okay. Doesn't do what we expect it to do, right? Because it's now kind of drawing over the same section of the screen over and over again. So now what we have is this kind of X pattern. Cool, but what we'd like to do is we want to fill the whole screen up. So what do you think we need to change to make this draw line function fully dynamic? We're going to create all the parameters will be dynamic. Look at this draw function, this draw line function. Which one of these parameters is not dynamic right now? Boom. I hope you guessed it. It's that 0, right? What do we want to make this 0? Instead of making it X, we're going to make it Y, right? We throw that Y in there. Now all of these parameters are dynamic. Now if we hit play, what? Boom. Now we have a pretty interesting display here. And if we hit play again, it's completely dynamic. Every single one of these generations is going to be completely different. So you're essentially getting a different maze. And I wonder, I've never tried, but I wonder if you can actually get from one point to the other point in this maze. But this is essentially a maze generator. Now, fundamentally, what we did is we segmented out the entire canvas into a row and a column using for loops. So loops enabled us to iterate over the entire screen in a certain step size, right? If we modify the step size, say for example, we make this 30, actually we could turn on auto refresh now because we know our loops work. We make this 40. Notice how we're kind of like zooming in, right? And if we make this 5, we're going to zoom all the way out and we have this kind of Aztec looking pattern. Now, some of you may still disagree that this is not really art, but I think at this point, some of you would convert to say, hey, this is a type of art. This is a type of artistic expression. And quite honestly, we see some of these patterns even outside of computational art or this generative art in things like what I just said with the Aztecs and things like that, like different patterns that we write on walls or wallpapers and things like that. So this is kind of an interesting exercise to go through. It's not a lot of lines of code. And for those of you that are interested to see how this may work without using the P5JS library, I'm going to link in a site. It's a really great site because this is not, I didn't make this up. This is a piece of work that's out there, and it's kind of like it is a pretty popular tutorial on basic generative art. And there's a site here called Generative Artistry. And this is a bunch of awesome tutorials, and there's an accompanying podcast that these guys put out that you can look at some very famous pieces of work. here. And each one of these, like the classic circle packing algorithm or the cubic disarray, which cubic disarray, this piece right here is in museums. And they, George Nees, this was, I think, in the 60s or the 50s. He is a old school generative artist, and he did a lot of initial exploratory work in this space. But the cool thing about this artwork is the fact that you can do exactly what we just did, is you can go through the steps to recreate it. And then you can also experiment with modifying it and changing it. Like, for example, if you wanted to go ahead and maybe randomize the color of the line, right? So instead of drawing a fixed black stroke, maybe inside of this draw line function, you go ahead and you randomize the actual stroke color, right? That might look interesting. Or maybe you randomize the size. That might look interesting too. So you can kind of create these derivative works off of this. But I will link this site up, and this site does have a link to tutorials on how to do this. The difference is, though, and this is a bit more advanced, I encourage you to explore this. This is not using P5.js. So this is using direct JavaScript in the browser. It's dynamically creating canvas elements. It's using what we call the DOM inside of JavaScript and the browser to be able to create everything that we just did, but without the P5.js library. So I encourage you to take a look at this. I'll link this in the course alongside this assignment. And really the deliverable for this assignment is to basically follow along with exactly what I did. But what I'd like to see is a small tweak to this. Try to change it in some way. Either make the colors different, make the fill different, maybe even try a different piece of geometry here, if that makes sense, right? And see what it would look like. Experiment. Try to kind of break it. Now, the only thing with that, with saying break it, is when you're using these loops, make sure that you have this auto refresh turned off. Because if you get into an infinite loop situation, which I did once in this video already, it's going to crash your browser and you're going to have to crash out of it and you're going to lose some of your code here. So you don't want that to happen. Also, you want to make sure you save your stuff. So I'm going to go ahead and actually do that right now. But yeah, that's pretty much it. So play along. I didn't want to make this too long. I think we're on good time here. And we'll discuss this a bit more on Monday. All right? Have fun. Thanks.